Let's start the next part of matrix representation. Already we discussed adjacency matrix representation. Uh, Next, adjacency matrix representation for connected undirected graph, adjacency matrix representation for diagram. Now we are discussing adjacency matrix representation for disconnected graph. So what is disconnected graph? Disconnected graph means between every pair of vertices, if they are having no path, then this type of graph is called disconnected graph. And then what is the definition of adjacency matrix for disconnected graph? Suppose G be a disconnected graph with two components G1 and G2. Then the adjacency matrix of the disconnected graph G can be represented as A of G, AG1 null matrix AG2, where this is the null matrix and AG1 and AG2 are adjacency matrices of G1 and G2 respectively. Next, find the adjacency matrix of the graph. Which type of graph is it? This is a graph G. We can see between V1 and V6. Is there any path? No. So this type of graph is disconnected graph. Disconnected graph means between any two pair of vertices there exists no path. So there exists no path. Disconnected graph is written as A of G. This is A of G1 null matrix A of G2. So this is the null matrix. A of G1 and A of G2 are the adjacency matrices of G1 and G2 respectively. Now here I am drawing this graph V1, V2, V3, V4. Okay, this is our graph V1, V2, V3 and V4. Next is V5 and V6. V5 and V6. This is our graph. Okay, so this is our G1. So in G1, how many vertices are there? 4 vertices. I write all the vertices in row wise and column wise. V1, V2, V3, V4, V1, V2, V3, V4. First I am choosing V1. So V1 connects V2, V3, V4. So V2, V3, V4 all get 1. V2 connects V1, V2 itself, V3, V3. No V4. So V1, V2, V3 all gets 1. This is 0. V2 to V4 there is no connection. Then V3 connects V1, V2, V4. V3 connects V1, V2 and V4 all get 1 and V3 is 0. V4 connects V1, V3. V4 connects V1, V3. That is AG1. AG2 is what? This is our G2. AG2 V5, V6, V5, V6. So V5 connects V6, V6 connects V5. So this is our AG2 and we know this will be written as actually AG1 null matrix AG2. This is the writing pattern. This is the writing pattern. In G1, how many vertices are there? 4 vertices. 1, 2, 3, 4. 4 vertices. AG2. This. So this is AG1 null matrix AG2. This is AG1. This is AG2. These two null matrices. So this is a procedure how to find matrix from the disconnected graph. Next, graph is one matrix is given. We have to draw the graph. Same procedure we can separate the null matrices. We can separate it from here. We can separate it from here. 0 1 0 1 0 1 0 1 0 0 0 0 0 0 0 0 0 0. This is 0 1 1 1 0 1 1 1 0. So in G1, how many vertices are there? V1, V2, V3. This is the actually this is your AG1. This is the null matrix. Null matrix. This is AG2. In G1, how many vertices are there? 3. V1, V2, V3. So we plot these 3 vertices V1, V2, V3. Then V1 connects what? V1 connects V2. V1 connects V2. V2 connects V1, V3. V2 connects already V1 and V3. V3 connects only V2. That is done. This is G1. These two null matrices. This is the place for AG2. This is the place for AG2. So V4 connects V5, V6. V4 connects V5, V6. V5 connects V4, V6. V5 connects V4, V6. And V6 connects V4, V5. V6 connects V4, V5. So this is AG2, this is G1, and this is G2. So previous case is the adjacency matrix representation of the disconnected graph. Now we are discussing incidence matrix. So again we are discussing these 3 cases for incidence matrix. First case, undirected connected graph. Second case, directed graph. Third case, disconnected graph. So first we are discussing incidence matrix of an undirected connected graph. First we have what? We have a graph G, V and E. V be an undirected connected graph with n vertices and n edges. Suppose G contains no self loop. Then the incidence matrix I of G equals to Aij n by n, whose rows correspond to vertices and columns correspond to edges, is defined as follows. How will you write it? Aij equals to 1 if jth edge Ej is incident on either vertex Vi, 0 otherwise. Next, features of incidence matrix for undirected graph. First one, each column of I of G has exactly 2 unit entries. Number 2, degree of the vertex Vi is equal to the number of ones in the ith row. Number 3, all zeros in a row of Ig correspond to an isolated vertex. Number 4, the parallel edges in a graph produce identical columns in its incidence matrix. These are the features that we have to remember. Next, find the incidence matrix of the graph given below. This is the graph. We have to find the incidence matrix. So here we are writing all the vertices in row wise, all the edges in column wise. In this graph, we can see 5 vertices are there. We are writing all these 5 vertices in row wise: V1, V2, V3, V4, V5. All edges E1, E2, E3, E4, E5, E6, all edges in column wise. Now we are considering one edge. Suppose we are considering edge E1. Edge E1 connecting V1 and V4. Edge E1 connecting V1 and V4. Edge E2 connecting V1 and V5. Edge E2 connecting V1 and V5. Edge E3 connecting V2 and V4. V2, V4. Edge E4 connecting V2, V5. Edge E5 connecting V3, V5, V3, V5. Edge E6 connecting V2, V3. So this is the matrix. This is the writing pattern. So first we are considering one edge. That means we are writing this in column wise. We are considering one edge and we are checking this edge connecting which 2 vertices, and we put these 2 in the place of these 2 vertices. We are putting 1 and rest will be filled by 0, this column. Next we are considering the next edge and we are considering this column wise. Then in this column wise we are putting these edge connecting which 2 vertices, that will get 1 and rest vertices will be getting 0 in column wise. Next, find the incidence matrix of the graph given below. So we can draw the graph. Okay, we can write one matrix of the first graph. We are writing the first graph. So how many vertices are there? V1, V2, V3, V4 and V5. This is I of G. This is I of G. This is E1. This is E2, E3, E4, E5, E6. Next, we are considering AG1. AG1 connecting 2, 3. AG1 connecting 2, 3. Both get 1. The rest will be filled by 0. Edge E2 connecting V1, V4. Edge E2 connecting V1 and V4. They will be 1. Rest will be 0. Edge E3 connecting. Edge E3 connecting 2, 4. Edge E3 connecting V2 and V4. They are getting 1. Rest will be 0. Edge E4. Edge E4 connecting V4, V5. V4, V5. Rest will be 0. Is E5 connecting V1 and V4. E5 connecting V1 and V4. Rest will be 0. Is E6 connecting V1 and V3. Rest will be 0. This is the matrix of this graph. Similarly, from this graph, we can find incidence matrix in this way. Next, matrix is given. We have to draw the graph. Matrix is given. We have to draw its graph. For this student, what we are doing? How many vertices are there? V1, V2, V3, V4, V5. So we plot them. V1, V2, V2, V3, V4 and V5. V1, V2, V3, V4 and V5. V1 connecting first. Is V1 connecting V2, V3. V2, V3, that is our edge E1. Edge E2 connecting V1, V4. V1, V4, that is our edge E2. Done. Edge E3 connecting V2 and V4. V2, V4, E3 connecting V2, E3 connecting V2, V4. E3 connecting V2, V4. E5 connecting V4, V5. V4, V5. E4 connecting E4 connecting V4, V5. E5 connecting V1, V5, V1, V4. E5 connecting V1, V4, V1, V4. That is E5. Is E6 connecting V1, V3, V1, V3. That is E6. This is the writing pattern of our graph. Now this is the graph. It looks like good from mine. So you do it in this way. There are another two matrices given. You have to draw its graph. I think you can easily do it. Next, incidence matrix for directed graph. This graph is connected, but a directed graph is there. That means our graph having some particular direction. Now we are starting. Let we have a graph G. It has vertex set V and edge set E. B a directed connected graph with n vertices and m edges. Suppose G contains no self-loop, then the incidence matrix I of G equals to Aij n by n, whose rows correspond to vertices and columns correspond to edges, is defined as follows. So Aij having three values 1, minus 1, 0 when it is 1, if jth edge Ej is incident out of either vertex. If our directed edge out from that vertex, it gets 1. It gets 1. If our jth edge Ej is incident into the vertex, it gets minus 1. Otherwise 0. So now for directed graph of the incidence matrix, we are having three types of elements 1, minus 1, 0. This is one incidence. We have to find the incidence matrix of the following directed graph. We can see this graph is directed. Why? Because every edge has a particular direction. So this is the directed graph. Now we have edge E1 connecting V2 to V1. So edge E1 out from V2 into at V1. So out from V2, that means this is 1, and V1 this is minus 1. Edge E2 out from V2 into V3, out from V2 this is 1 into V3, that is minus 1, raised will be filled by 0. Edge E3 out from V4 into V3, out from V4 into V3, that is minus 1, raised are filled with 0. Edge E4 out from V1 into V4, out from V1 into V4, that is minus 1, this is 1, raised are filled with 0. Edge E5 out from V2 into V4, out from V2 into V4, that is minus 1, raised are filled with 0. Edge E6 out from V3 end at V1, out from V2. Edge E6 out from V3 into V1, that is minus 1, out from V3, that is plus 1, raised as 0. For edge E6, E7 out from V4 into V1, out from V4, that is minus 1 into E7, that is plus 1. Edge E8 out from V4 and into V3. So this is minus 1, this is 1. This is the case. This is the writing pattern. So we can write it in this way. Our next, we have this graph. We can easily draw its matrix. I of G. So vertices are V1, V2, V3 and V4. Edges are E1, E2, E3, E4, E5. Edge E1 connects V1 and V2. So out from V1 it will get 1 into V2, that is minus 1, rest will be filled with 0. For edge E2 out from V2 into V3, E2 out from V2 into V3, that is minus 1, rest will be filled by 0. For E3 out from V3 end at V4, out from V3 and end at incident into V4, minus 1, rest will be 0. For E4 out from V1 into V4, out from V1 into V4, minus 1, rest will be 0. for E5 out from V1 into V3, that is minus 1, this will be 0. So this is the procedure. From the directed graph we can write the matrix. Similarly, one graph is given, you can write the matrix. Try it in home. Next, matrix is given, we have to draw the graph, but if matrix is given, we know it will be directed graph or undirected graph. If minus is there, three types of elements are there, 0, 1, minus 1, then obviously directed graph. If only 0 and 1 is given, it is undirected graph. So first consider the AG1. So V1 1, V4 minus 1, so direction towards V4. This is AG1, direction towards V4. For age E2, V3 V4, age E2 connects V3 V4, direction towards V4. This is done. For age E3, this is V2 V3, age E3 V2 V3, direction towards V3. That is done. For age E4, that connects V1 V2, age E4 connects V1 V2. That is age E4 connects V1 V2, direction towards V2. That is done. Age E5 connects V2 V1, V2 V1, direction towards V1. That is done. And age E6 connects V3 V4, V3 V4, direction towards V3. That is done. So this is the procedure. How will you draw the matrix, draw the graph? So there are another two matrices given. We can draw its graph so easily. So I leave it for your homework. So thank you. This is up to this. Again, we recall what we are doing in this class. So we are starting with disconnected graph for adjacency matrix. This is the definition. Then we discuss examples. We write the matrix from the graph, disconnected graph given below. Next, matrix is given. We draw the disconnected graph. Then we are discussing the incidence matrix for connected graph, undirected. That is a definition. Example graph is given, how to write the matrix. Graph is given, write the matrix. This is for your homework. Matrix is given, how to draw the graph. We show it. Two matrices are given, try to draw the graph in home. Then we are discussing the directed graph. Three types of elements are there, 1, minus 1, 0, that is here. Then one directed graph is given, we are writing the matrix. So this is another one example. Then matrix is given, we draw the graph. Then these two for your homework. Thank you. We stop our presentation here. Next class we discuss the next part.